Good morning, good afternoon, ladies and gentlemen. Welcome to this series of online lessons. If you haven't already, subscribe to the channel and leave a like for this lesson. Now, in today's lesson, we are going to look at orthogonal vectors, and right off, we can start with the definition. So, two vectors, or let me say orthogonal vectors. Okay, orthogonal vectors. So we'll say two vectors u and v. So for convenience, let's use u and v. Are said to be orthogonal if they are perpendicular. So they have to be perpendicular, number one. Number two, and their dot product. So hope you remember how to find the inner dot product. Their dot product u comma v is equal to 0. So for orthogonal vectors, there are two things that we should know. Is that vectors that are orthogonal simply means they are at 90 degrees, okay, from each other. Then when you multiply when you find their dot product, you're going to get 0. So this is actually what we use to if the two vectors are orthogonal. We just get their dot product, and when we multiply, we evaluate the dot product, we get 0, then we conclude that the vectors are orthogonal. And that simply means they are perpendicular to each other. And by perpendicular, we mean they are at 90 degrees with each other. So if this is one vector and that is the other vector, like that, so we see that they are at 90 degrees like that. So meaning that if this is u and this is v, then we conclude that these vectors are orthogonal. So, but the easiest way is just to find their dot product, and if the dot product gives us 0, we conclude that the vectors are orthogonal. If the dot product doesn't give us 0, it gives us any other number, we conclude that they are not orthogonal or they are not perpendicular. So let's look at an example. All right, so determine if the following pair of vectors are orthogonal. So we have these two pairs, u is equals to 1, 2, 3, 4, v is equals to that. So the first thing that we have to do is we need to find the dot product. So in simple terms, we can start with the following statement. So whenever you're solving such questions, start with the statement: if u and v are orthogonal, then u comma v, which is the dot product, is equal to 0. So when solving, always start with this statement to support what you're doing. So now here we can find the dot product of u and v. So now we'll come to u comma v. So u comma v will basically be equal to multiplying the corresponding terms. So this times that. So this will be 1 comma 2 plus 2 here times the 2 here, so that is 2 comma 2 plus the 3 and the 5 there, so that is 3 comma 5 plus the 4 and the 6 there, so that is 4 comma 6. Okay, so I'm presuming you remember how to evaluate the dot product. So that will give us 1 and 2, so this will give us what? That will give us 2 plus this, that will give us 4 plus that will give us this times this, that will give us 15. and this times that will give us, so this will give us 24. Then we add everything up. This will give us 45. So 45, which is not equal to 0, then we say therefore u and v are not orthogonal. Okay, so that is our conclusion. So this is why it's important to start with this statement that we started with here, so that we can make a conclusion based on that statement. So we found their dot product and it gave us that. So whenever you get two, it could be functions, because remember we also talked about functions, finding the dot product of functions. So it could be functions that you want to find the dot product of. So if you multiply those two functions, you find their dot product, and if it gives you 0, then they are orthogonal. Okay, so same applies for vectors. So now since we did a bit of the dot product for different types of functions, let me just give you this task to just check, because we'll just be finding the dot product of these functions, then we see how we move on from there. All right, so you have these three questions. Determine if the following pair of vectors are orthogonal. So we have u, which is equals to 6, 7, 8, 1, w, which is equals to negative 1, 0, 0, 6. The second one, f is equals to x, g is equals to cos pi x, f comma g is equals to, or interval, sorry. So f is equals to x and g is equals to cos pi x, and f and g are part of this interval. Then m is equals to this, 0, 3, 7, and v is equals to that. So these are the two questions. So now from this, there is another part of orthogonal vectors that you should know. So this is the first set of questions that you're going to do. So this is your task. Submit that. But there is another part that we should look at when we're talking about orthogonal vectors, which is determining vectors that are orthogonal to a particular vector. So let me give an example here. All right, so like this question here that asks you to determine all vectors orthogonal to the vector v, which is equals to this. So this is similar to the last question in your tutorial for inner product spaces. So that will be your activity. But this question is very simple. It's a procedural question, meaning that once you follow the exact steps that we're going to do here, then you'll be able to answer any question concerning this type of question. So this question asks you to find all vectors orthogonal to this vector v. Okay, so now remember from what we've said, so if two vectors, in fact we'll start with this. So we'll let u equals to a vector. So this can be any vector. So we'll let u, it can be even v, whatever we choose, but it should be more like different to this one. So we'll let this vector have the same dimensions as this given vector. So this vector has dimensions 1, 2, 3, 4. Okay, so we'll let another vector u have the same dimensions as this one, so but it will have vectors alpha 1 comma alpha 2 comma alpha 3 comma alpha 4. Okay, so if this had 5, meaning that this would also have 5. If this had 6, this would also have 6. So determine all the vectors orthogonal to this. So that is v is equals to 1 comma 3 comma 1 comma 5. So we let u have the same number of dimensions as the given vector. So this is 1, 2, 3, 4, and we're going to have 4 vectors, alpha 1, alpha 2, alpha 3, and alpha 4. So now remember what we said. If two vectors are orthogonal, so we'll say if u and v are orthogonal, so if u and v are orthogonal, then u comma v should be equal to 0. So this will be our starting point. So we'll say, we'll find u comma v. So we'll say v comma u. It's the same thing since multiplication is commutative. Will be equal to, so remember how we find the dot product. So we'll say this value times this. So we multiply them correspondingly. So 1 times that. So the 1 comma alpha 1 plus this times that, so that is 3 comma alpha 2 plus this and that, that is 1 comma alpha 3 plus, so this and that, that is 5 comma alpha 4. Okay, and this should be equal to 0. So let me just pull it up here. So this should be equal to 0. So that is according to the definition of the dot product. Now we can simplify so that we have an equation. So that is this times this, that will be alpha 1 plus 3 alpha 2 plus alpha 3 plus 5 alpha 4, and this should be equal to 0. Then now here you can make any of these subject of a formula. Okay, so for the first one, we'll make alpha 1 subject of a formula. So that is let alpha 1 equal to this. So we transpose this, that will be negative 3 alpha 2 plus alpha 3, or minus, sorry. So we make, so this will transpose, it will be negative alpha 3, negative 5 alpha 4. Okay, then from here what you're going to do is remember this vector that you had, which is your u, which is equal to this. Okay, so remember your u was equal to, we can even write it in columns. So let's write it in columns so that we have alpha 1, alpha 2, alpha 3, and alpha 4. Okay, so now what you're going to do is you get the value that you've made subject of a formula of, and you're going to replace it here in this vector. Okay, so here we've made alpha 1 subject of a formula, so we're going to replace it here. So we say u will be equal to, so where there is alpha 1, we're putting this, so that is negative 3 alpha 2 minus alpha 3 minus 5 alpha 4. Then we'll write these values that are here as they are. So but we can do well to align them under the specific values. So we have alpha 1 down here, so we can align it under alpha 2 here, we can align it under alpha 2. Then we have alpha 3, we can align it out under alpha 3. Then we have alpha 4, we can align it under alpha 4. Okay, now once we have done this, then we've already found the first pair of vectors that are orthogonal. So what we're just going to do is we're just going to create a small grid. So this is the first grid that we're going to create. So it should have like that. Then we can separate the grids like this, so such that the alpha 2s are in the same grid, the alpha 3s are in the same grid, and the alpha 4s are in the same grid like that. Okay, so if you check under your alpha 2s, there is this part, there is no alpha 2 in this column, so we just put a 0. Okay, so we'll put a 0 alpha 2 because there is no alpha 2 here. Here again on alpha 3 in this column there is no alpha 3, so we'll put a 0 alpha 3. Same applies here, there is no alpha 4 here on this column, so this would be 0 alpha 4, and we'll put some plus signs there just to accommodate for what we have. Okay, now what we're just going to do is we're going to get the coefficients here. So the coefficient here is 1. Then we'll separate them. So for alpha 2 in the column, we can factor out the alpha 2. Then we just get the coefficients here, which is negative 3, 1, 0 plus. For alpha 3, we do the same. Then we just put the coefficients here, which is negative 1, 0, and here the coefficient is positive 1, which is positive 1. So this is for alpha 3. And we do the same for... No. Sorry for that. Okay, just a minute here. I think I didn't align this properly. Let me just redo that. So I didn't align it properly. Let me just redo that. Apologies. So we have u. So let's start from here. Okay. So far you have made alpha. You've chosen whatever value you want to make subject of a formula. Here we chose alpha 1 to be subject of a formula. Then what we'll do is we'll replace this in here. Okay, so hope you were able to see the mistake that I made. So I wrote 3 vectors, but alpha 1 is subject. So where there is alpha 1, we'll replace with this, which is negative 3, alpha 2, negative alpha 3, negative 5, alpha 4. Okay, then we have the second one, which is alpha 2. We can write it under here. So alpha 2. Okay, let me just put lines to guide me so that I don't make the same mistake again. So I have 4 slots. So, but no need for you to put these lines, but they are just acting as a guide for me so that I don't mix up values. So we have 4 slots. Just okay, so I don't make the same mistake that I made. Okay, so what we've done is so we have alpha 2 here, then alpha 3 comes in the third slot. So this is alpha 3, so we write it under alpha 3. So alpha 3, let me use white. So let's say this is alpha 3, and the last one is alpha 4, which is in the last row here, which is alpha 4. So what you have to check is the number of rows. So we have 1, 2, 3, and 4. So alpha 1 is in the first row, and we've replaced with alpha 1, we've replaced with this. Okay, we've replaced with that. Then alpha 2 is in the second row, so we write it under the second row. Alpha 3 is in the third row, we write it in the third row. And alpha 4 is in the last row, so we write it in the last row. Then we close the brackets like that. So the mistake I made was I miscounted, so it is something that you should also look out for. So that is that. So there are 4 entries, 1, 2, 3, and 4. Okay, if we made alpha 2 subject, we would have replaced alpha 2 here, and we would have alpha 1 on top there, then and so on and so forth. So now this is what we have. So now we can make the grid that I was talking about. So this is also just a guide. So now we'll say the alpha 2s should be in a straight line, the alpha 3s should be in a straight line, and the alpha 4s in a straight line like that. So that when we make our grid, a small grid, let me just use a thinner pen. Okay, so when we make our grid, we have like that, then like that. Okay, so we have 1, 2, 3 variables. So we have 3 grids, and we have 1, 2, 3, 4. Now here, where there are no values, we'll put zeros. So this will be plus 0. So plus 0. This should be alpha 3 columns. So this will be 0 alpha 3. And this is alpha 4 columns. So this would be 0 alpha 4. And here there is no alpha 4. So this is 0 alpha 4. Then here, the alpha 2 here, we should have 0 alpha 2, since there is no alpha 2, and here 0 alpha 2. So same applies here. It should be 0, alpha 3. Okay, so we check the columns. So there should be 1, 2, 3, 4. So that is for the first one, we have negative 3, alpha 2. So we put like that. So this is 0, 0, and this is 0, 0, like that. So now once we have done that, what we just have to do is we get the coefficients of the columns. So getting the coefficients of the columns and making vectors. So getting coefficients of columns and making vectors. So getting coefficients. Okay, coefficients of the columns. Okay, so we just get the coefficients of the columns and we'll make our vectors. So for the first one, we have negative 3, so it'll be negative 3. The second one, the coefficient here is 1, so positive 1. Here we have 0, 0, 0, 0, so that will be our first vector. The second vector, we get the coefficient in the column, so this is negative 1, negative 1, 0. The coefficient here is 1, 0, so that is the second vector. And the third vector is negative 5, negative 5, 0, 0, and the coefficient here is 1, so 1, like that. Okay, so we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So these are vectors that are orthogonal to V. So we can check it out. So remember so UN as these vectors, which is this, and now we have the vector V, which was equal to, so the vector V was equal to what? 1, 3, 1, 5, 1, 3, 1, 5. The vector V was 1, 3, 1, 5. Okay, so now if you check 1 times negative 3, that would be negative 3. Then 3 times that will be positive 3. When they add, they will give us 0. 0 times this will give us 0. So these vectors are orthogonal to this vector. Okay, so now we have, let me just run you through what we did here. Okay, so the first thing is we were asked to determine all vectors orthogonal to the vector this, which is equals to this. So now we let a vector, any vector of our choice, be equal to the same dimensions as this, but we use the alpha 1, alpha 2, alpha 3 as our known values. Then from there, we put the statement that if these two vectors are orthogonal, then their dot product should be equal to 0. So we find the dot product of this vector and the one that we made up, and we have, we're going to have, so the dot product we equate it to 0, and we're going to have a function like this. So here we can choose to make alpha 1 subject of a formula, or alpha 2 or alpha 3 or alpha 4 subject of a formula. It's still the same. Okay, so now we said, let's make alpha 1 subject of a formula. So we're going to have this. Okay, then now we're going to get the vector that we made up. Okay, we take note of the entries. We replace the value that we have here in the vector that we made up. So we replace with alpha 1, we replace with this, which is this. Okay, then we are going to align these vectors in such a way that they're in the straight line as the function here. So the first one is alpha 2, so we put it under alpha 2, but in the row that it is in. So this is in the second row, this is in the third row, and this is in the fourth row. So the grid guides you so that you don't mix up like I did. So that is alpha 2 in the second row, we put it under alpha 2. Alpha 3 we put it under alpha 3 in the third row. Then alpha 4 is in the fourth row, we put it like that. Then now we fill in the squares here. So this is the coefficients. We take note of the coefficients because these are the vectors that are orthogonal. So that is the shortcut that you can take. So I'm sure if you make this or you understand this, it will be easier. So here what I want you to do is the same question. You're going to make alpha 3 subject of the formula and replace where there is alpha 3 and find those vectors. Then after you find those vectors, you make alpha 4 subject of the formula, replace where there is alpha 4 and find those vectors. Then you make alpha 3 subject of the formula, you replace where there is alpha 3 and you find those vectors. So this is the task that I'm giving you before you attempt the other question. So I just want to see how you've understood the question. So you make, if it's, you start with alpha 2, you make alpha 2 subject of a formula, you repeat this stage, then you replace where there is alpha 2, then you find the vectors, then you make alpha 3 subject of a formula, you replace where there is alpha 3, you find the vectors, then you make alpha 4 subject of a formula, you replace where there is alpha 4 and you find the vectors. So let me just see how you do that. So you just follow the same steps that we've taken. So so this is the first question, or let me say this is the first question that you have. You have these vectors here that you're asked to determine if they are orthogonal. So that is the first question, determine if the following pair of vectors are orthogonal. And after you determine that, you come to this question to find all vectors orthogonal to this vector here. So now you just use, first of all, I want you to find for alpha 1, for alpha 1 we've done, so you do for alpha 2, alpha 3, and alpha 4. Then after you're done, I'll give you a question on that. All right, so for now, it's a good evening. I'll be waiting for your feedback.